So good afternoon. I hope everyone had a wonderful lunch and a great morning. I think this is just a fantastic conference. We've been coming here for the past couple of years, and the topics just get deeper and deeper each year. And we're really thrilled to be invited to come speak about what we do. Again, I'm Kevin O'Brien. I'm the CEO of Orbital Insight. We're based out in Palo Alto, California. We're a team of about 115 largely engineers and folks in product and marketing. And what we're here to do today is a couple of things. One, tell you about what we do. Give some examples both in the commercial markets of how we support our clients, and then also really dig into some of the important work that we're doing for national security, both from a security standpoint, but also from a humanitarian standpoint. And then if there's any questions at the end, I'm happy to take those as well. So we wanted to get started to talk about what's going on. We'll talk about AI, geospatial intelligence. There's a lot of folks like, can you actually define that a little bit in a more granular way? We've really helped build out the category from a software and analytics standpoint. So we'll go deeper into that, give you some real world examples, and then a couple of key takeaways. What we really want to start with is, as we all experience right now, there's a lot going on in the world. There's a lot of good things happening in the world, and there's a lot of bad things happening in the world. So you've got all of the issues around supply chain disruption. We've got all the volatility in the financial markets globally across many different asset classes. It's hitting many, many different sectors. We have obviously the horrible activity that's going on in Ukraine right now, which has been developing now for a couple of months. And then you have even the longer term aspects of things like climate change and other natural disasters. And so you have this culmination of events, and it really begs the question of, how do you actually try to stay on top of this? How do you kind of get insights from what's happening in this very interconnected world? And that's where we feel Orbital Insight has a very special place to be able to really look at some of the legacy ways that folks have gleaned insights. You get it from kind of the traditional printed media in the past. There's a lot of news networks now that have different levels of coverage happening in the world. And then you've got a lot of new social type of applications coming out as well. But there's also always a latency effect. Latency in terms of the time delay of finding out what's actually happening on into the earth in some type of a real-time basis. And with latency comes risk. And so when we looked at this, we said you have those traditional sources, but there's also now an ability to be able to use AI-driven geospatial intelligence, leverage all of the investments that you're seeing in the space industry, which they're extensive in terms of launch, in terms of satellites, in terms of communications, in terms of data and value-added services, and to be able to really look at this from a different lens. If you think about satellite constellations, if you think about some of these new networks, they can literally paint the entire planet on a very near-time basis with the number of launches that we have been seeing, and that's a really good thing. But with that, it introduces some problems. Like, how do you actually consume all of that data? How do you take in electro-optical imagery coming off of platforms? How do you take radar-based sensors? How do you take in billions and billions of anonymized cell phone pings or ship pings? So these are all wonderful sensors, and they're compressing time. The challenge is, can you compress time and process it at scale and deliver those insights back out to the market, whether it's a commercial market, whether it's a humanitarian market, or national security, and we serve all of those at once. And so this was the big idea that we came to. We started the company about 8 years ago. We've been on AWS since day one, and we'll talk about that journey as well. And it started with satellites. One of the first questions someone would ask me, like, how many satellites do you own? And we say the biggest piece of hardware we own in our company are Mac laptops. We have no hardware whatsoever. We're just tapping the growing network, the growing ecosystem of geospatial sensors, and then fusing those. And that's the really hard bit that we'll go on to in a second here. When you fuse those insights, you can get a strong signal from one, but when you put two or three together, you get derivative insights off of that. And you can get it in a more compressed time period, meaning it can be delivered to you in a more real-time basis. And that can lower your risk, can help you take better operating decisions, can do better humanitarian type of activities as well. But you need to pull all of that together, and that's basically what we're doing here at Orbital Insight. So what's an example of that? People have heard about artificial intelligence. They talk about machine learning and computer vision and data science. We do all of that. As I mentioned, most of the folks in our firm are engineers, super bright engineers. And what they're doing, a lot of what we do is take in all of these different sensors, especially from satellite-based sensors, and we take in and blend things like computer vision of leveraging all the networks to be able to pick up object and change detection, and then we're fusing that with other geospatial sensors, anonymized geolocation devices, mobile devices, for example, ship data, airborne data, terrestrial sensor data, and then open source. And so you've probably seen some examples of, well, here's a ship in a port, and it's been picked up on a satellite image. That's interesting, but what we do is basically a number of things. In this example, you can go count the ships in the port, but then at the same time, you can also look at AIS transponder data in the harbor and correlate that to ship activity, and then hit using what we call traceability to see where are those ships going. So for example, yesterday, like where are the Russian trawlers going that have been taking grain out of Ukraine and going down to Syrian ports? You can do that with AIS traceability. You can actually use computer vision to count the ships in the harbor, and that's again what we're doing with our computer vision engineers. There's anonymized geolocation devices and sat phones as well, so you merge that into that operating picture. And then you can even do things like counting foot traffic or counting the number of trains or cars or trucks. So you're taking these multiple views of one AOI or an area of interest, and you fuse that together, and what you're getting is near-time situational awareness. And it could be literally anywhere on the planet. And that's the beauty of this entire industry that's growing up so rapidly and that we're so excited about. So this is, for all of the engineers, this is what we do. It's a lot of stuff, so please don't lose your vision on this. But going from the left to the right, as I mentioned before, we take in an extraordinary amount of content. Take petabyte after petabyte after petabyte of satellite data. We take in about 700 to 800 billion anonymized cell phone pings every day. And we extensively use AWS S3 to take all of this into the cloud. And then we start doing some things around like cloud detection, orthorectification, geo-registration to kind of clean up a lot of these sources. And that's where we begin to hand it over to our engineers. So we use EKS, for example, for scaling out 1,000-node production Kubernetes clusters is another thing that our computer vision engineers are doing to be able to do a lot of the heavy analytic steps in the background to eventually produce object detection and change detection models using that particular sensor. Then if you go to that lower, below that dotted line, we take in all these other sensors, so anonymized geolocation, airborne, and whatnot. And then we do things like noise filtering and user painter filtering and ground truth normalization. So it's really hard to work with data, but what we're doing with AWS is making it easier, first and foremost, for our engineers to work with it, because that's the complex bit. So if you can use like EMR, for example, it enables our team to use Spark, to be able to do some testing for computer vision and data science models. And it helps us basically kick out the end product, which is geolocation analysis. And then we fuse that with these other types of algorithms. And then lastly, we're taking in a lot of open source data as well. So you hear AOIs, or areas of interest. So it could be a port, it could be an airfield, it could be a shopping mall, it could really be anything on the planet. And we simply mark it, and then we hit it with our software and look for that change detection. And then through AWS, we pump all of that out to our customers. So we don't do anything locally. We're big users of GPU farms, and I've got the bills to prove it, to be able to kind of process this at scale, because those are the best platforms to be able to use to process this type of imagery. And so then at the end of the day, what we're doing is delivering this to our institutional clients. We're going to talk about some of our public sector work, but we also wanted to talk about a lot of the commercial work that we do. And the key message, or one of the takeaways, is that there's a lot of dual use capabilities here. You'll see some things that we do with our commercial customers here in this next video that have direct application to some of the very work we do at the Pentagon and some of the intelligence agencies, and also for law enforcement. So a little bit of a story. When I first interviewed at this company, I've spent most of my career working in financial technology. So I've been selling to like asset managers and banks and stock exchanges all over the world. And my background was largely about fusing disparate sensors and sources to be used for things like risk management and trading and other types of financial and commercial workflows. And I sat down with the folks at Orbital Insight and they said, so have you ever worked with satellite data? And I was like, nope. And I thought, crap, this interview's over, I'm done. But it was basically, it was the ability to come in with a little bit of a different perspective. I didn't have a space background, but I was really focused on things like client pain points. Like how hard is it to identify where you can find new customers? What's happening in a particular market? And so we've got dozens of customers, like Fortune 500 customers that are using the Go platform. That's what you just saw there. We integrated into Esri, we do it to other platforms as well, and we're trying to democratize or really simplify more of the geospatial analytical workflow, and that's really what's been very, very exciting about this, is bringing some new perspective into solving economic problems. And so now we're going to turn the page and get really, really serious about what we're doing on the humanitarian side, and then also on national security. We're obviously all tracking what's happening in the world, especially in Ukraine. And when we looked at this, we said, let's just take our commercial software and just port it over. We already have it up in AWS. And so let's start opening this up. We started having communications with some of the folks downrange in Ukraine saying, what do you need? And they said, we're blind. We can't see what's happening. We're getting some imagery coming in, which is helpful. We're getting some intel inside of certain aspects of Ukraine. But there's other things happening, and largely about humanitarian disaster from day one. So I think up to this point, there's about 11 or 12 million internally displaced persons, or IDPs, people that have had to leave their homes in Ukraine and mostly go west and a bit go south. But the Ukrainians, as well as the folks in the intelligence community, had said, we have a really hard time tracking this. And we said, well, shoot, if we can actually look at shopping malls in the United States to look at types of movement, why not just do that across Ukraine? And so we fired up some projects. This took about an hour or two. We picked 47 of the largest cities in Ukraine. Obviously, Lviv and Kyiv were a main focus of it. But as you can see through this time series, when the invasion began, you'll see this migration of thicker color patterns. And sadly, that's humanity on the move. And they were able to use that to look at things like from humanitarian support. Where do we need to start building refugee camps? Where do we need to have food and shelter and water programs? What are the safer routes to do that the Russians are not bombing, which is the case in the past couple of weeks? They try to get an evacuation zone, and they're like, okay, that's not going to work. What's plan B and plan C? And I can't wait 2 to 3 days. I need it in 2 to 3 hours. And that's the power of cloud-based analytics in real time. So this next view is kind of an animation, and it'll show you that's literally the movement of millions of people over a five-day period. And so they have greater clarity of what's happening, situational awareness on the ground, and to be able to do better planning. There's some other military applications we've been working on as well, but this has been the number one thing of how do we help protect people and lives, and then infrastructure, whether it's agricultural, water systems, transportation systems, medical facilities. In our world, they're all AOIs. They're things that you can basically tag and map and track. So whether it's for battle damage assessment, whether it's for refugee analysis, whether it's for war reparations, which we're talking to a couple customers about, we're doing all of this on the low side. This is not up on JWICS, on the high side. And we can deliver this on a 24/7 basis out to different customers. This is a slightly different view of, sadly, when a person gets to the border, they're reclassified from an IDP to a refugee. And so where do we see the flows of people going up to all the different border crossings, largely in Western Ukraine? And then how are they flowing into other countries in the area or throughout Europe? Again, it's to track really what the impact is, and ideally of how do we begin to get those folks back to their home country when this conflict ends. And then here's the last point of, once they've crossed, where have they gone? And this is just a couple of different sensors that we've used. This is an example of Budapest. You can begin to see the clustering of where different refugees are beginning their journey and ending their journey in this particular case. So let's go from Ukraine, and now we're going to go hop over to a different part of the world, down in the Middle East. So again, this could be an analyst at NGA, could be at CENTCOM, could be at JSOC, could be at INDOPACOM, could be at PACFleet. We have a number of users in the Air Force that are using this now. And this example is looking at a particular airbase in Syria that you can monitor, again, all on the low side. And then the system will pop up saying there's some unusual activity over the last 2 to 3 months. We've run pattern analysis of aircraft movement, and they've just had a different type of aircraft show up. And in this case, the example that we showed up was basically like an E-2 Hawkeye. Basically, it's radar communications. And so when US military found out about that, they said that changes the risk level to our strike patterns. So if we've got F-18s or others in the area, knowing that they've got better command and control, that's going to be a higher risk to our flight crews. And so this, again, was all being done just on the low side, not even up on JWEX. If we use this same example, we do a lot of stuff around aircraft detection, multi-class aircraft detection, and that just started basically with, can you classify an aircraft? And we did with our computer vision engineers and some of our data modeling teams. And then the customers had come back, largely Air Force, saying, can you actually now classify multiple versions of that? So fighters, bombers, and helicopters. Our goal, we're doing some projects now with NGA, is some synthetic data projects to be able to map out rare objects, like different types, like you'll show the J-20 stealth fighter in China, or MiG-29s or Su-27s with higher degrees of precision to be able to feed into our models. In this case, in this island, in the Spratly Islands in the South China Sea, monitoring this one area called Mischief, and you can just go in and say number of bombers, fighters, and whatnot. And then again, we pick up some anomalous activity of there's a commercial aircraft that's shown up at that location. The idea is that we're augmenting the analyst. So we track 1,000 airfields all over the world, 24/7. Just counting aircraft and the disposition and change of those aircraft. And the idea is that you can simply alert, again, somebody might be in the field, might be a part of a squadron, could be a policymaker. You can deliver all of that same analysis to that customer using these types of tools. Talking about the J-20, it's an advanced drone fighter with the Chinese, and so we looked at this in this particular base. It's about 500 kilometers from Taiwan, and so the movement of those assets can be perceived very, very closely by the Taiwanese and the US military in INDOPACOM, like why are they moving and where are they moving? So in this case, we picked up, you're just monitoring that location, and then boom, you see a large change of the number of aircraft, of that particular aircraft, much closer to China, to Taiwan. Could be posturing by the Chinese, could be training, could be a number of things, but the idea is that you're using this technology to inform somebody that something's happening. Could be a false positive, but it could also be a precursor to some other type of activity. Here's another example again of moving from a test site, test and training base a couple thousand kilometers away, much closer to looking at the numbers on a daily basis. Are they doing training activity? Are they all J-20s? Are they different types of aircraft at that base? And again, you'll see in the video here in a second, the whole idea is to augment that analyst. Could be a kid 21 years old, straight into the service that doesn't have a lot of background. Could be an NGA analyst. Could be someone in PAC Fleet or INDOPACOM. Or it could be a senior commander or even a policymaker using the same type of analysis that we're delivering right now. And here's another example, again, of movement of the different J-20s over these different time periods. And then the green dots are picking up the indication of those fighters in that particular location. So monitoring at scale in one day, we mapped about 54,000 aircraft over 350 locations. And we'd say it's basically our technology. It's all of the engineering work that we've done, all the stuff we've been doing with the AWS team. And we did it at 343, and I was like, that's pretty neat. And then our engineers came back and said, we can do 1,000 now. We just had one of our first commercial customers come back and say, we'd like to now go from 5,000 locations that we're monitoring to 1 million, and then we want to do 30 million AOIs across the planet using your software. And I thought, good Lord, this is growing faster than even we thought. But again, the key thing here is that you're doing this to be able to support the analysts, to support the country, make things safer, and also from a humanitarian standpoint. So let me just run a quick video, and I'll give you a little bit more background on our aircraft detection capabilities. Oops.
Every day, intelligence analysts monitor high-priority airfields. However, with more satellites, UAVs, and sensors increasing the amount of imagery exponentially, it's difficult to analyze data efficiently or contextualize it to know what's going on at a global, macro, or micro level. Orbital Insight Go leverages machine learning and computer vision to automatically monitor thousands of air bases in near real time. Driven by AI, our software analyzes imagery of over 1,000 airfields across the world and automatically detects objects of interest so an analyst doesn't have to. Orbital Insight Go allows you to detect aircrafts, zoom into specific airfields, and see what is happening over time, helping you understand patterns of life and identify anomalies. Since November 2020, our system has classified over 200,000 airplanes by type, including bombers, fighters, and helicopters. Just define areas of interest and our platform will do the rest, expanding your missions to naval bases, commercial ports, or military facilities. Using Orbital Insight Go, you could monitor any facility in near real time that humans otherwise wouldn't have the time to watch. And with seamless integration, you can analyze results in ArcGIS or a visualization tool of your choice. Orbital Insight Go helps you analyze situations, detect anomalies, and visualize dynamic threats on a global scale to succeed in missions of today and tomorrow. Learn more at www.orbitalinsight.com.
Pretty cool, huh? So that's a military application, but you could also look at it and say, is that a commercial application? At the beginning of COVID, one of our largest financial services customers, Royal Bank of Canada, called up and said, we need to monitor Chinese aircraft activity. And we're like, why? They said, well, we want to basically look at all the major airports in China and look at the drop of commercial activity going in and out of those airports. And we said, why? It's like, that way we'll get a better idea of the spot price of jet fuel. And they put that into one of their reports like a week later. And that was one of the first applications of this being used by institutional customers. So hopefully what you're seeing here is 1 minute we're talking about aircraft, the next minute we're talking about cars or trucks or planes, or you're talking about different asset types. We're building out more and more algorithms to look at different AOIs and asset types to support humanitarian missions, to support national security, and also a number of commercial applications. And the beauty is that dual use capability, that you can use it for different types of customers and sectors. And that leads to economies of scale. And one of the key things that we've learned over the years, especially working with the Amazon team, is how do you use this kind of global cloud-based production infrastructure to do really complex things, but then to simplify it down to a level where you don't need to think about all of these sensors. You don't need to think about cleaning and orthorectification and all of that. We do all of that bit. And we do it all up in the cloud, and we do it in a real-time basis. And the goal is to deliver this down into an application that's super easy to use. And so that's what we do every day. We're really excited about it. We love the partnership that we have with the AWS team. We wouldn't be here, quite frankly, without them. Or if I had $1 gazillion, we'd go build our infrastructure. But instead, we spend a lot less than that with the AWS team. But hopefully, you're seeing some things from me today that spark some interest of, well, could you support this other use case? Could you support other ways to reduce risk? We're always about trying to improve efficiency, finding new types of customers for people, and then lowering risk. And if we take anything out of this market right now, there's loads and loads of risk out there. And we just think the future is to be able to use geospatial software and analytics in a way to lower that risk profile. Whether you're in the national security, whether you're in law enforcement, whether you're in humanitarian organizations, we're here to help. So with that, we've got a few minutes left. I'd be happy to take any questions that folks may have. Anything from you folks. Hi.
I can see it. All right, thank you. Yeah, I was just wondering, as it pertains to conflict zones, how do you collect all that anonymized cell phone data?
I'm sorry?
As it pertains to conflict zones, for example, Ukraine you were showing, how do you collect all that anonymized cell phone data? Is that coming from governments or?
No, there's different types of commercial sensor providers. They're all GDPR compliant. We have extremely tough, very rigid privacy guidelines as well. We do the same thing with like AIS ship transponder data. We're taking in ADS-B aviation data as well, and then we're looking at things like connected cars and trucks. We don't do any type of tracking of individuals. You basically cluster that. There's no PII whatsoever. And again, the beauty behind that one was when we looked at what was happening in Ukraine, we've also done some work with the World Bank around poverty, and to look at movements and say, is there a better way to distribute food and resources to others in the world using those types of sensors? You're welcome.
Oh. I was just wondering, looking at this, how easy it would be, or whether you've encountered any of our adversaries spoofing the data in terms of making it look like it's a certain type of aircraft.
Spoofing?
Yeah.
We actually have a couple of contracts right now for that very issue. Because again, the engineers, when we came in, we first started taking in a lot of these data sources. Started with electro-optical, which is super hard. I mean, radar is wickedly hard to work with as well, but we're very good at it. And when you started to get anonymized geolocation coming in, our engineers would come back to us saying, well, something doesn't make sense here. I mean, they're just wickedly smart people, and this was spoofing in that. And so we actually built out filters, and a couple of my colleagues that are here today came across some programs being sponsored by DIU and some others saying this is a big issue. As you're seeing it all the time now in Ukraine and in Russia as well. And so we have a CBER contract right now specifically looking at spoofing. Hi.
Hi. A lot of vulnerable populations don't have those sensors for different reasons, children or impoverished populations or the elderly.
Sorry,
So-
would you mind speaking up a little bit?
I'm sorry, can you hear me now?
Yeah.
So a lot of vulnerable populations don't have sensors.
Yep.
So what do you do to help track them?
Well, actually, like I said, when I came to Orbital, they had said, hey, we have this really fascinating project with, we're monitoring poverty across Sri Lanka. And I said, how in the heck do you monitor poverty? Because they don't have any geospatial sensors, but satellites pass over. And so you can go in and look at a village and see, are there new roads being developed? Are there more cars there? Is the ground being changed? And so we started to develop algorithms in these areas that didn't have a lot of sensors, but you still have other sensors passing over them on the satellite side. And so we've used that type of innovative creativity to come in and say, this is the type of change that we're seeing in that area. And then if you have new sensors come in, then you can actually begin to blend those to kind of increase the strength of the signal that you're trying to find, whether it's object detection, change detection, population movement, and things like that. There's a couple of sensors. We're doing some other testing, some ground-based sensors that are coming online. People are talking about IoT. I mean, when you think about satellites, you think about anonymized cell phones and other devices. They're all IoT devices at the end of the day. And making sure that you follow the strictest privacy and ethics guidelines and do that in a way that's positive to help your customers. We think there's a lot of growth in that market. And then lastly, I'd also say that what we've also seen, and we've been pushing this with the intelligence community, is there's a lot of very rich open source, non-classified sources that you can basically take those and fuse those with proprietary sensor data to get even a stronger signal. And we've seen that. I've done that for years in the financial services market, and now we're doing that for humanitarian and commercial and national security workflows as well. Sure.
So a few times there you talked about the strength of signal. Mm-hmm. How is that confidence level presented to the user?
It's not, there's never perfection. If you came in and said, we are at 100% certain that this is like the perfect F1 score, we have F1 scores, which is like the accuracy recall rate of like when we do car detection, we were known for that in the early days. It's like 0.97. It's actually more accurate than a human. That's extremely hard to do. And so what we do is we publish all of our test results and we publish our F1 scores out to all of our clients and say there's a 75% chance that this is a MiG-29 versus an Su-27. And we continue to work on that to improve that. One of the key things is ground truth data. You know, it's very hard to find North Korean mobile missile launchers because there's not a lot of pictures of them. Synthetic data can help you not only build out a model, but strengthen and increase the accuracy of that model to have higher recall and precision on that. So it's kind of it's an ongoing kind of process to just continue to improve it, to eventually make sure that if an analyst looks at it and they say, okay, I'm going to use this, I could use it for economic analysis, risk analysis, national security, humanitarian work. That's the ultimate decider of, can I use this in my current workflow? Great questions. Thank you very, very much.
Yeah, thank you, Kevin. Round of applause for Kevin.